Hello guys and welcome. I hope that you're having a good day or a good morning or a good evening. My name is I play 4K, aka I play 8K, aka I play 16K, or UHD King. During this video today, I'm going to show you the world's first Dying Light gameplay in 12K resolution, which pretty much 3 8K resolution screens. Width of those 8K resolution set as height, so 7680 pixels will be our height. Pretty much it's a width of the 8K resolution display. How I achieve that? Pretty much I'm using the 8K native resolution display plus the Nvidia DSR method. This is going to be the native Nvidia DSR method. It's not going to be the third-party DSR method. This is very important because sometimes when I was testing the third-party DSR methods back in 2016, 2017, and 2018 on the 4 Titan X Maxwell GPU architecture, 2 Titan XPs, during some of my videos, not all of the videos, just few of the videos, the FPS and VRAM utilization is not equal to Nvidia DSR method, and I believe that Nvidia, the company that releasing the making video cards, know exactly how to set the display resolution and how to emulate the display resolution, because pretty much today we're forcing our computer to render 12K resolution, and then we downscaling to 8K resolution for me to see it. Plus I'm recording this video today with Nvidia Shadowplay technology. It's a software. It's recording my screen on the same computer, so it's utilizing the same video card resources. So go ahead and add 3 FPS to the FPS counter. It's exactly 3 FPS without the recording. Keep that in mind. So 12,960 by 7,680 pixels. I'm going to start with the lowest possible preset, and then we're going to go ahead and bump it up. Let me show it to you. And I'm using today the Titan RTX video card that is completely stock with dual fan Nvidia cooling solution and thermal paste compound by Nvidia as well. I did not use the liquid metal thermal compound paste on this Titan RTX yet. Let me go ahead and turn on the anti-aliasing. Okay, no anti-aliasing. And I'm using the old school Xeon E5-2697 V2 CPU. That is the 12 physical core CPU, 24 virtual cores or 24 threads CPU from 2013. That was priced $2,500 during that time, and this is my workstation for 2020. I'm about to retire this workstation in 2021, but it's still a great low budget workstation for video encoding and 3D rendering when you're utilizing all the 24 virtual cores, such as 3ds Max rendering application when you're doing the 3D and rendering it, or FFmpeg++ application that I'm developing right now. It's a freeware that's going to utilize all the way to 144 CPU cores, and it's capable to encode your videos all the way to 16K resolution, the world's first 16K resolution video encoder, developed by UHDking or by iPlay 4K, aka iPlay 16K, and it's going to be a freeware, guys, based on the FFmpeg DLL libraries. But anyways, so I'm recording this video with Nvidia Shadowplay, and the Nvidia Shadowplay is hacked as well. Width and height is changed, the values width and height is changed on a video container through a system RAM debugging tool in real time during the runtime. So go ahead and watch this video in 8K resolution on YouTube. Just go ahead and click YouTube video resolution and change to 4320p or 8K resolution for the best possible scenario. Okay, and add the 3 FPS to the FPS counter at the left top corner. As you can see, self-explanatory. So let's go ahead and get going, guys. Enough of the explanation. In the end of this video, I'm going to show you CPU Z, IDA 64, GPU Z, MSI Afterburner, and we're going to talk a little bit about my hardware. Let me remind the purpose of this video is gameplay. RTX is the first video card that allow us to run Dying Light PC game in 12K resolution. Before, Titan XPs or Titan X Maxwell GPU architecture wasn't capable to do so. Keep that in mind. 16K resolution is crashing on the Titan RTX video card, and I believe it's just because the VRAM is not enough. Alright. So as you can see at the left top corner, 16 FPS, and the VRAM utilization is almost 17,000 megabytes, which is 17 gigabytes, and the system RAM utilization is almost 11,000 megabytes, which is 11 gigabytes. Total system RAM utilization can go all the way to 32,000 megabytes. Keep that in mind. It's running quad channel 4 sticks of the 8 gigabytes DDR3 because I'm running it on a socket X79, socket 2011 version 1.1 and chipset X79. And as you can see right now, Titan RTX is stock 16 FPS, right? So let me show you the difference, stock versus the overclock. Also at the left top corner, you can see that I'm only running right now 2 cores, and I disabled 10 physical cores in the BIOS. My Gigabyte X79 UD3 version 1.1 BIOS allows me to disable the CPU cores, and I disabled the hyper threading technology, so this enterprise CPU is not allowed to overclock through the multiplier. Keep that in mind. And you can only overclock it through some techniques and through the BCLK frequency. Through the BCLK frequency, maximum overclock will be 200-400 megahertz. It depends. And then the CPU is using automatic turbo boost, so to use in that automatic turbo boost maximum multiplier, you gotta disable some cores, and 1 core on this CPU from stock will be 3.5 gigahertz, 2 cores 3.4, 3 cores 3.3, 4 cores 3.2, and then all 12 cores 24 threads at 3 gigahertz. 30 multiplier, because 100 megahertz BCLK plus multiplier, 30 multiplier 3 gigahertz, 32 multiplier 3.2 gigahertz, 4 core 4 threads. But in my scenario, additional 200 megahertz boost through some technique, overclocking through the BCLK, not through the multiplier but through the BCLK, and disabling some CPU cores to boost up to 36 multiplier, not 36 but 34, because only 2 cores, 34 multiplier used by Intel pre-built motherboard BIOS and CPU and Windows operating system drivers, Intel drivers, use 34 multiplier on this particular CPU. So additional 200 megahertz overclock, as I told you. So no matter what kind of scenario we're running, but this is the fastest possible scenario for this game in 12K resolution. The higher resolution, the less CPU cores you need. Keep that in mind. This is also the algorithm that if you my watcher since 2016, you already figure out. So let me show you 17 FPS, right? Let me overclock the video card. Usually the overclock gives us additional 10% of boost. Keep in mind that my desktop right now is running 12K resolution as well at 100% scale. In the end of this video, I'm going to demonstrate it to you. So I'm going to go ahead and overclock it. 1000 megahertz on the GDDR6, which is our VRAM, which is times 2000 megahertz of the boost, 16,000 megahertz output. So from 14,000 megahertz to 16,000 megahertz plus the GPU overclock additional by 100 megahertz. Okay, beautiful. Okay, immediately boosted up to 18 FPS, 19, so by 2, makes sense. 10%, just like I told you. So this is maximum possible scenario, guys, running right now. And just because of recording with Nvidia Shadowplay, so you gotta add 3 FPS additional. Keep that in mind. So pretty much overclocking through the software, as I just did, going to boost it up and give us the performance boost, just like we are not recording with Nvidia Shadowplay, so we can compensate it. Alright, let me escape over here. As again, I didn't play this game for a long time, but the purpose of this video is to benchmark so we can compare with the future video cards, future CPUs, and future PC builds. Keep that in mind. This is a great scene to test it because a lot of 3D geometry here. Every single zombie is 3D model and has a lot of polygons in it. So let's go ahead and have a look. This is lowest possible preset. Okay. Alright. Alright, this is not good. This is not good, guys. I gotta escape over here. People are running after me, huh? I'm playing without the headsets, keep that in mind, and just disable the speakers so I cannot hear what's going on because I'm echoing my microphone, and I find out that it's canceling the noise, so you're not hearing the fan. But single Titan RTX is kind of noisy video card, keep that in mind, especially when you're recording the sounds through the mic, it can pick it up easily. 14 FPS, so pretty much 15-18 FPS average, not bad. Everything at the lowest possible settings. This game supports SLI, keep that in mind, so I'm going to show you probably on the same workstation, as again, this is my workstation for the 8K resolution video encoding and 3D rendering. This is not my gaming PC, guys, but I'm going to show you the Dying Light PC game running 12K resolution on 2 Titan RTXs, and probably also going to be my workstation, this same workstation, and I'm also going to show you my gaming PC as well, so keep that in mind. You gotta take it easy. As you can see, there is a lot of zombies. Alright, so we saw pretty much alright guys, we saw the let's say the FPS. Okay, there's a bunch of zombies. We better take it easy. But beautiful visuals, even at the lowest possible preset. The game's still looking great. A bunch of zombies. Alright, okay. Oh, that was evil. Yeah, so it's not playable status, guys. Not comfortable for sure. Kinda sort of playable, but as again, not comfortable at all. Let me go ahead and start playing with the presets. Minimum preset doesn't look too bad, actually. Almost 17,000 megabytes of VRAM usage, as you can see at the left top corner. Oh Jesus. Alright, 14-17 plus 3 FPS, so around 20 FPS, alright? Let me go ahead and start pulling some settings. As again, this is the world's first 12K resolution, guys, and it's not going to be a fast video, so I'm going to show you all kind of different presets. Go ahead and grab yourself your favorite drink. The best drink will be tea, green organic tea. I like the raspberry tea, organic, and the lemon. Just go half or quarter of the lemon in it. Make sure you're putting the lemon when it's not so hot. Try it, you're gonna love it, guys. Try it for 2 months, you're gonna get healthy and feel so great. So foliage, let's go ahead and start implementing some settings and see how it's going to change. As again, this game supports SLI, and I'm going to show you the SLI. So it means the 2 Titan RTXs in SLI, and performance will be 1.9 times faster FPS that you can see right now. That's going to be in another video, and I'm going to show you on this system. I'm about to wrap up with this system, as again, this is my workstation from 2000. In 2021, I'm going to build myself a new workstation with the 2 Xeon E5-2697 V3 CPUs with the hot hacked Chinese bias, motherboard bias, and hopefully overclocked to 3.4-3.6 per each core instead of 2.4, and beat up the Ryzen 5950X and 3960X with the 72 virtual cores or 72 threads total on the dual socket. Those two CPUs I got it for $129 each. Was amazing deal, used like new. So this is guys kind of preset that we're going to go ahead and use. Increased, as you can see, and the FPS almost the same, which is nice, but visuals increased now on another level. Now we have the foliage everywhere. Shit, that green thing, amazing. Alright, let's go ahead and try to explore a little bit of the level. Back to 20 FPS. Of course, there is no such a lot of zombies because each zombie is 3D model with a lot of polygons. As you can see, FPS is increasing. Guys, keep in mind that I also recorded on this system 8K resolution and 4K resolution. Go ahead and check it out over the UHDking.com or iPlay16k.com or iPlay8k.com or iPlay4k.com. Going to be great videos. Wow, look at this. That's great. The game looks great actually. Even at low presets, visual presets, it doesn't look so bad. Because when you're playing 8K resolution and above, you're rendering so many polygons and pixels on the screen, and the pixels creating a difference, guys, believe me or not. And even if it's downscaling to 8K resolution screen, when you're playing 12K resolution, it's rendering 12K resolution, and you can see it clearly, even on downscale, that this is not the 8K when you're comparing regular 8K to 8K. Alright, beautiful. So, pretty much we saw it, there is no such a difference. And keep in mind that, let me show it to you, that we have something that we cannot change, which is the texture quality right now at medium. We could set it to high, but pretty much when it's on medium and everything else right now going to be maxed out, but as again without the ambient inclusion and without the anti-aliasing, and I did not use any Nvidia presets yet. In the end, I'm going to show you the Nvidia presets, so we can bench it and test it against the AMD Radeon video cards in the future. 20 FPS, look at this, the same FPS pretty much. Yep, same. What was that? Oh, that dude right there is dangerous. It's multiple. Jesus. He's going to come or what? He wants to come. He just doesn't know how to. Huh. Jesus, even during the day this game is not safe. By the way, if you like the single player game or even multiplayer, this game is amazing. Dying Light PC game. This is the following, the enhanced edition, which is pretty much going to have the same visual in the original game, keep that in mind. So it's just going to be the same deal. FPS will be the same and performance, but I was always benching in the following version. So oh, look at this, all kind of different zombies. Jesus, made a lot of noise. A lot of folks disappointed. Alright, so yeah, pretty much nice. Beautiful presets. Let's go ahead and keep moving. As you can see, 18 FPS, very nice. Still doing great on the Titan RTX video card. 99% GPU utilization. So this value right here you want to keep your attention at 99% right here. CPU utilization, when CPU utilization doesn't reach 90% during our gameplay or above 90%, that means that you don't need to add additional threads or better additional cores. So we are healthy in our CPU cores, as you can see. We're not bottlenecking, and that means that this is the maximum possible stable frequency pretty much in the home safe environment for the Xeon E5-2697 V2 CPU. If you're playing games, this is how you want to run it in this particular game at 12K resolution. As again, the higher resolution, the less CPU cores you need, and the less CPU actually you need. And yeah, you can still utilize this game even playing extreme ultra high HD resolution. Keep that in mind. So let me go ahead and bring some ambient inclusion now. But still, anti-aliasing will be off. Ambient inclusion consumes a lot of resources. Keep that in mind. What is the ambient inclusion? Pretty much it's like shadows outline in Photoshop. So inside of the layer, creating the shadows on the edges. So pretty much every single model on every single edge right there of that model will have the shadows. It's a fakey shadows, like creating like fakish global illumination. Keep that in mind. Jesus, those guys want to have me, huh, for breakfast. Let's put some fire. Let's make some fire over there as well. You can see the latency delay is 70, so this is why it feels like a little bit like a slow-mo, because high latency delay. The latency delay below 30 is playable status, below 20 is comfortable status, below 10 milliseconds is amazing playable gameplay status. Above 30 milliseconds, the latency delay already is at a status playable but not comfortable, and above 40 milliseconds, it's a benchable status. Keep that in mind. Alright, so by 3 FPS actually. It lasts about 3 FPS. Alright. So let me real quick go ahead and quit the game. And I'm going to switch to textures at high instead of medium, because we cannot change the textures while we're in the game. Texture preset. So texture preset, we'll go to the maximum, which is the high. Okay. Ambient inclusion on, anti-aliasing is off, and I'm not using any AMD presets yet. So this is how we're gonna do that, guys. Okay. I don't like the film grain effect. I don't like the chromatic. It's like ruining the quality to me. So those effects doesn't take maybe maximum 1 FPS. Okay, so let's go ahead and execute the game. So this is, guys, with the will be on, and then I'm going to go ahead and enable some maximum possible scenario for the Xeon, old school Xeon system. So this is a great all-in-one system, guys, and in the end of 2021, in the beginning of 2022, this processor will cost around $79-$89 on the eBay, used like new. I purchased it for $129, but in the end of 2021, in the beginning of 2022, it's going to be $89, and it's a great build, especially for the Chinese motherboard for $30. It's a great workstation to render some 8K resolution videos and to do some 3D rendering, 3ds Max like applications, such as utilizing all the cores. So you will utilize all the threads and take the advantage of this CPU, all of those cores, and it's overclockable. But if you want to have the best for the money, I advise you to go ahead and grab yourself the V3 version of the Xeons. V3 version of the Xeons. Oh Jesus. yeah, take the V3 version of the Xeons to take the full advantage, because it's overclockable. You can hack the BIOS of the motherboard and push it harder and farther in terms of the megahertz, and in the PC games you will take advantage of that, and pretty much megahertz will take advantage anywhere where's the CPU computing. And about the same price, it will cost you about the same price, so completely makes sense. So as you can see, 14 FPS, we went from almost 20 to 14, I would say 18 to 14, but everything maxed out except the anti-aliasing right now, which is amazing. Amazing visuals, by the way. Jesus, those zombies. Not joking around, huh? Alright, now they're going to run here. So I better jump into the water real quick. Right? Look at this. So still with the heavy actions, when there is a lot of 3D models going to go to 11, even a lot of particles right now, as you can see, after the blowout. Oh, Jesus. Right, let me use the medkit real quick. Almost jump out, huh? This game is amazing, but as again, right now it's kind of slideshow, and I know that. Again, this is the first video card that allow us to run this game, so we're not looking to have the best FPS over here.
Face me like a man.
Jesus. Uh-oh, we jump. Okay, let's go ahead and enable the anti-aliasing, and we're going to go ahead and wrap it up, guys. So, great video, great benchmarks, but we gotta keep moving. So everything was mixed out, and in the drivers it's set for the maximum performance, by the way, in Nvidia drivers. So, anti-aliasing is on. That's crazy, guys. FPS, as you can see. So go ahead and make some fire. Too bad it's not like in Far Cry 3 when it can just go ahead and... Oh, there is a zombie behind us. Oh my god. So I better switch the weaponry. So 12 FPS with the anti-aliasing, guys. Look at the VRAM utilization and oh Jesus, this bloody guy is dangerous. Look at it, there is a fish right there. Could be a zombie as well. With the anti-aliasing, guys, the VRAM utilization is still below 20 gigabytes. The system RAM utilization below 10 gigabytes, as you can see, or 10,000 megabytes. Still, RAM utilization is still not so bad. Jesus. Okay, alright. Yeah, but VRAM utilization can go up all the way to 20,000 megabytes. That I saw, guys, while I'll just warm up just a little bit when I play it, and it's easy. So I would say 18/20,000 megabytes VRAM utilization. And for the Titan RTX, this is the maximum runnable resolution, because 16K resolution is crashing on this system on the Titan RTX with some errors, so keep that in mind. Alright, that's pretty much it. And let me go ahead and enable some Nvidia presets for those who's curious, and after that point we're going to go ahead and wrap it up. So pretty much that was maxed out, but we can enable some Nvidia presets. Let me go ahead and do that, like HBAO and Nvidia depth of field. That's going to go ahead and stress our system even further than that, and FPS will decrease. But this again just to test all the presets, so in the future we can test it with the future systems. FPS. We increased in terms of our VRAM utilization, as you can see, above 20,000 megabytes. So here we go, the Nvidia presets of some filters consuming some VRAM, as you can see at the left top corner. The information system that is updated every second, and fan rotation 100%, GPU utilization 99%, which is amazing. This is exactly how we want to keep our GPU utilization. So we're going to raise as last shader cores or CUDA cores as possible, as last. So when it's 99%, which is not, oh god, Jesus, man. Gotta be careful, there's some zombies coming and coming. Alright guys, so pretty much this is maxed out, 11 FPS. So it's still like 11 FPS, 10, 11 FPS. And on the workstation, with the better CPU, the FPS is going to increase as well. Keep that in mind. This is important thing to understand. Jump into the water, boom. Yeah, and as again, it's crashing 16K resolution. So let me show you about the system, and we're going to go ahead and wrap it up. Guys, don't forget to smash that like button. A lot of time, money, energy is invested, and this is the world's first 12K resolution. Come on, in dying light. And as again, on a gaming PC with i9 9900K overclock at 5.3 gigahertz that I was using in 2019 and 2020. It's a 9th gen Intel i CPU cores, and this CPU is the Xeon E5-2697 V2, is Intel 4th gen, so 5th generation from this gen, and every single next generation in CPU will give you additional 3% of the boost when we are talking the Intel i, starting first generation and all the way till 10th generation. Next generation gives you as minimum 3% boost. It's like 3-7% boost in terms of the CPU computing. This is in real life performance. This is not the theoretical performance. So 3 times 5, 15% of the boost, plus that CPU is running 5.3 gigahertz instead of 3.6, so almost 2,000 megahertz or 2 gigahertz additional boost. So I would say 20% of the FPS should be boosted in real life performance, but I'm going to show you that video on that gaming rig, and there's again all kind of different gaming rigs and workstations in the future. But let's go ahead and have a look. First of all, let me show you that my desktop is set 12K resolution, 100% scale as well. This is important when you're running something as a windowed mode. Here we go. And as again, I was running windowed mode because full screen is crashing on Titan RTX above 8K resolution, and even the 8K resolution doesn't want to go to the full screen mode. I'm not sure why. But anyways, let me tell you about the system. So this is the system that I was running, as again Intel Xeon E5-2697 V2. 10 cores was disabled in the BIOS, and hyper-threading technology was disabled in the BIOS. So I was using only 2 physical cores, 2 physical threads to be able to boost it up to 3.6 gigahertz or 3600 megahertz per each core. 30 megabytes level torch shared cache means that between 2 cores shared, 15 megabytes per each core. Nice. And the motherboard Gigabyte X79 UD3 version 1.1, which is the ultra durable 3. This is version 1.1 with the F20 BIOS downloaded from a Gigabyte website from March 19, 2014. This is the only BIOS that can run post this CPU on this motherboard. So Gigabyte having some issues in terms of the socket 2011 version 1 for the chipset X79. It's not like ASUS. ASUS was the best for the X79 because they have the BCLK stripping ability, and this Gigabyte doesn't have it. So I overclock my BCLK by 6 megahertz additional. So this is my trick. This is my trick and trick. So from 100 megahertz I went to 106 megahertz, 6 megahertz additional. It times multiplier right now 34, so it gives us 3.6 gigahertz or 3600 megahertz. So instead of 3.4 gigahertz or 3400 megahertz, which is 100 times 34, it's 106 times 34, 200 megahertz additional boost, no matter what kind of presets you're using on your turbo boost. It's kind of tricking, overclocking. Hopefully this makes sense. And quad channel DDR3, of course. DDR3 is only on this motherboard supported memory. 4 sticks, 8 gigabytes, and CL9 1T command running 565 megahertz times 2, 1130 megahertz. And this memory is 1866 megahertz CL9, but on this particular CPU, on this particular motherboard, 1130 megahertz is the stable possible frequency. I can go all the way to 14,000 megahertz. It's bootable, but then it's going to blue screen after 20-30 minutes. So if you don't want to have the blue screen, 1130 megahertz. Even with the CL7 or CL8 or CL6 is blue screening under the CAS latency CL delay. Alright, hopefully this makes sense. As again, Titan RTX had 24 gigabyte of the VRAM GDDR6 by Samsung, same memory that on the RTX 2080 Ti video cards, but RTX 2080 Ti video cards only have 11 gigabytes, so they couldn't run this 12K resolution benchmark today. And RTX 2080 Ti and the GTX 1080 Ti cannot even run the 8K resolution because the VRAM overload. But I recorded on those video cards 4K resolution and 5K resolution that I'm going to upload for you to watch over the UHDking.com or iplay4k.com or iplay16k.com. Go ahead and check it out. But anyways, memory 8000 megahertz. Usually it's running 7000 megahertz. So times 2, 16,000 megahertz. My video RAM, which is the VRAM. This is the IDA64 GPU benchmark, OpenCL API, where we can compare GPU versus CPU through the rendering. And of course, GPU will be much faster, but we can see how fast the GPU is. Keep in mind that during this benchmark, my video card was overclocked. So this is the value of the Titan RTX when it's overclocked like that. 100 megahertz on the VRAM and plus 100 megahertz on the GPU. And the CPU was running only 2 cores, and this benchmark was done without any recording. So all these benchmarks was done without any recordings. Keep that in mind. This is the value under the CPU-Z. Excellent dual core value right now. As you can see, 2 times scaling, which is amazing. And why it's doing that? Because huge level 3 shared cache, and it's boosting up CPU very well. So this CPU is working very well with the excellent CPU scaling, like in real life, like in theory, all the way to 4 cores. After 4 cores, it's scaling going, you know, worse and worse. But 4 cores is amazing on this CPU particular, okay? And just because that heavy level 3 cache is again boosting up that CPU as well, ability to pre-cache and do a faster computing. So guys, here we go. Look at this value, GPU-Z. Pixel fill rate 179 gigapixels, textual fill rate 538 gigatexels, and bandwidth 768 gigabytes per second. This is the overclock values of the Titan RTX. I'm gonna bring it to stock. Here we go. Right now it's running stock, controlled by the drivers. And as you can see immediately, pixel fill rate 169 gigapixels by 10 gigapixels down. Textual fill rate 509 gigatexels by 30 gigatexels down. And bandwidth 672 gigabytes per second by about 80 gigabytes per second less. Okay, so when the Titan RTX VRAM is overclocked, it's almost as fast as RTX 3070 or 3080 VRAM, which is the GDDR6X, which is faster bandwidth memory. A hair slower our GDDR6 when it's overclocked, but still we're boosting a lot of performance, as you can see. Alright guys, So that's it, guys. That's pretty much it. And as again, when Titan RTX is stock at 7000 megahertz on the VRAM, which is times 2, 14,000 megahertz. So guys, I showed you everything what you need to know. You saw everything what you need to know. Let me as again show you that I was recording during my break today. January 12, 2021. The world's first dying light 12K resolution. Pretty much 3 8K resolution monitors in vertical width as height. Alright? Don't forget to smash that like button, subscribe, positive comments, and I will see you guys till the next time. As again, I play 4K, aka I play 8K, aka I play 16K, or UHDking, what we do today. Stay safe, have a great day, till the next time.